Scene script. Imagine this. You're working on an electronics project that involves sensing a tiny, delicate signal. The signal is so subtle that it's almost drowned out by the noise around it. Maybe you're trying to measure the temperature changes in a room using a thermocouple. Or perhaps you're working on a heart rate monitor that picks up the faint electrical signals produced by the heart. In scenarios like these, an indispensable tool in your electronics toolbox would be the instrumentation amplifier. So, what exactly is an instrumentation amplifier? An instrumentation amplifier, often abbreviated as IN-amp, is a specialized type of amplifier that's designed to accurately and precisely amplify small, differential input signals. It's like the high-precision scalpel of the electronics world, enabling you to extract and amplify tiny signals from a loud, noisy environment. Think of it as trying to hear a whisper at a rock concert. The whisper is the signal you want, and the rock concert is the noise you don't want. The instrumentation amplifier essentially turns up the volume of the whisper, while leaving the rock concert noise unchanged. Output. Now, let's demystify how an instrumentation amplifier works. An instrumentation amplifier consists of 3 operational amplifiers, also known as op-amps. The first 2 op-amps form an input stage where each of the input signals is buffered and amplified. The third op-amp, the differential amplifier, subtracts these 2 signals and provides further amplification. This design ensures the amplification of the difference between the input signals, while rejecting any signals that are common to both inputs. In other words, the instrumentation amplifier amplifies only the difference between the input signals, ignoring anything that's the same on both inputs. This property, known as common mode rejection, is what makes instrumentation amplifiers so useful in noisy environments. Output. To wrap up, let's summarize the key points we've discussed. An instrumentation amplifier is a special type of amplifier used to amplify small differential input signals. It's like a high-precision scalpel in the electronics world, allowing you to extract and amplify tiny signals from a noisy environment. The working principle of an instrumentation amplifier involves 3 operational amplifiers. The first 2 buffer and amplify each of the input signals, while the third subtracts these signals and provides further amplification. This design results in the amplification of the difference between the input signals, while rejecting any signals common to both inputs. Instrumentation amplifiers are indispensable tools in many areas of electronics, particularly in scenarios where you need to accurately measure tiny signals in the presence of noise. So the next time you're struggling to pick up a delicate signal, remember the instrumentation amplifier, your high-precision scalpel for signal amplification.